Right. Watt hour. Watt in the sense joule second minus 1 hour 3600 second. So this will be 3600 joule. So 1 watt hour is equal to 3600 joule. So this is actually the unit of energy. Unit of energy. So the answer is the third one. Question number 2. The main scale of a vernier caliper is constructed by dividing 10 centimeter length into 200 equal divisions. So from that we can find one main scale division, right? 10 centimeter divided by 200. So that will be 1 over 20. 1 over 20 in the sense 0.05 centimeter, right? So this will be 0.5 millimeter, right? Like that. The vernier scale is constructed by dividing 12 millimeter into 25 equal division. So one vernier scale division equal to, right, 12 millimeter divided by 25. So that will be 0.48 millimeter, right? The question is the least count. Let's say the least count is LC, that is one main scale division minus one vernier scale division. So one main scale division is 0.5 minus 0.48. So this will be 0.02 millimeter. A tea strainer was slowly dropped by a man from a point above the ground, right? As given in the figure, the velocity v and the acceleration a of the tea strainer at a certain instant of the motion is given, right? At a certain instant of motion, the velocity and the acceleration of the tea strainer is given, right? This is line segment, right? Line segment, and it is given like this. Velocity is v and acceleration is a, right? The question is, after a while, after a certain time, right? After a certain time, right? What is the possible, right, representation of velocity v and the acceleration, provided that the air resistance is not negligible. Air resistance is not negligible. That means air resistance will oppose the motion of the strainer, T strainer. So that will, due to the drag, air drag, the acceleration will reduce. So definitely the acceleration will reduce. So if we want to represent the acceleration using a vector notation, that means a line segment, then that will be somewhat smaller than the previous one. But certainly it is the motion under gravity. So the velocity under the gravity, right? If an object is falling under the gravity, then its velocity will increase, right? For example, parachute, but it can reach a constant velocity, but that constant velocity will also higher than the initial velocity, right? So this will be somewhat bigger than the previous one. So the possible option is the fourth one. Fourth one is the possible option, right? So the standard model of an elementary particles, generally we can categorize into quarks and leptons. There are, right, these pink colors, look at that, quarks, 6 quarks and 6 leptons are there, right? The first one, up quark, down quark, charm, strange, top, bottom, like that. Leptons, electron, muon, tau, electron neutrino. Electron neutrino, the notation is like this, Okay, mu need to know, tau need to know. Like that, leptons are there, right? So the question is actually, right? If you read the question carefully, right? Which of the following represent, which of the following respectively gives the most stable quarks and leptons? Most stable, right? So before exploring which one is stable or not or something like that, right? You have to first identify the quarks and leptons among the given answer, right? There are some answers given. The first one is, this is the trick. First one is electron and up quark, right? We will write the answer and eliminate the wrong answer and find out the correct one. Second one is top quark and electron. Third option is, right, top quark and tau. Fourth option is down quark and electron. Fifth option is, right, strange and tau, right? So among these we have to find the stable quark. First a stable quark, then stable lepton, right? You need to know, right, the quarks or lepton, whatever, right? If it is a light particle, then that is more stable. Heavier particles are less stable, right? So before going further, first we need to identify quarks, then lepton. The first one should be quark, the next one should be lepton. Thereafter we can think about the, right, stable one and unstable one. Okay. Now carefully look on the answer. Answer number 1. Electron and up quark. Electron is a lepton, right? Electron is a lepton. Up quark is a quark. So the question is quark and lepton. So the order is missing. So this is wrong. This is wrong, right? The second one, top quark and electron. Top quark is actually comes under the category quark, right? Electron, lepton. So the order is okay. So this can be, but we don't know whether it is stable or not, right? So this can be, right? And third one, top and tau. Look at that top and top is actually quark. This tau is lepton. So the order is okay. So this also can be. The fourth one, down quark is a quark. Electron is a lepton. So the order is okay. So this can be. Fifth one, strange quark. Again, tau is lepton. So this is the answer we can eliminate. Other answer we have to carefully look on. That means based on the stable and unstable we have to eliminate, right? Now if you carefully look on that, read this. Most stable quark is up quark. Thereafter, this is the most stable. Thereafter, down quark is stable, and unstable quarks are strange, charm, bottom and top. So the most stable quark is up quark. Look at this. So among these, right, up quark is the most stable. So most stable should be the correct option, right? What is that? Quark should be up quark. So here it should be U. Only it should most stable quark. Most stable quark. Yes, most stable quark is up quark. Up quark is your fourth answer is down and E. Right. Second stable quark is down quark. So up quark is not there, but down quark is there. So this we can choose because down quark is somewhat stable, but it is the stability is below the right stability of this up quark. So we can choose this. Electron is also more stable, right? Among leptons, electron is more stable. Thereafter, neutrinos, electron neutrino, muon neutrino, tau neutrino. Unstable leptons are muon and tau. That you have to know. So the correct option is this one. Okay. Question number 5. is regarding the moon eclipse, right? The moon appear red during the total lunar eclipse. Lunar eclipse in the sense moon eclipse, lunar eclipse. Right now, if we draw some diagram to represent what will happen when lunar eclipse is taken place, sun will be here, right? This is sun, right? This is earth, and moon will be here, right? Earth and sun and moon will be in a straight line like this, right? During lunar eclipse, right? This is our earth, okay? Right, this is earth and this is moon, right? There are some statements given about lunar eclipse. Statement A: lunar eclipse occur when the earth, moon and sun align on a straight line. Sun, earth, moon, right? The order is, look at the order. Sun, earth, moon, right? All are aligned in a line, right? All are aligned in a line. So actually this is the order, but all three are aligned in an order now, so A is correct. So A is correct in the sense we can eliminate the fourth one. The possible answers are first one can be an answer, or second one, or third one, or the fifth one. B: presence of atmosphere in the earth is one of the reason why moon appear red during the eclipse. During the lunar eclipse, the moon appear red. Yes, earth is around the earth there is an atmosphere, right? So when light is passed through the right atmosphere, right, that will undergo refraction, right? Due to the refraction, right, moon will seem red. It will, right, scatter the red light, sorry, blue light, and moon will seems red color. So that is also correct. So the A and B are correct. So among these, A and B are correct. A and B correct in the sense second can be a possible answer, or the fifth one, right? C: particular medium having different refractive index for different colors of light, and red light having the lowest refractive index. Yes, you know, during the electromagnetic spectrum, right? This is the order: red, orange, yellow, green, blue, indigo, violet, right? The refractive index, lowest refractive index is red, then orange, then yellow, then green, then blue, thereafter indigo, Ni. right? Then violet, right? Also, you need to know refractive index is inversely proportional to lambda, right? If the wavelength is high, then refractive index will be low. So from this we can conclude, right? Red has the lowest refractive index, so higher wavelength. Lambda r greater than lambda O greater than lambda y greater than lambda g greater than lambda b greater than lambda I greater than lambda v, right? And the relation between frequency and lambda for an electromagnetic wave, right, in a particular medium here, right, air, atmosphere, right, because we are going to see everything through the atmosphere, right? So if the lambda value is high, then frequency will be low. So Fr will be smaller than F naught, sorry, F naught, yes. Then Fy, thereafter Fg, thereafter Fb, then Fi, then Fv. So these things you have to know. So the C is also correct. The possible option is the fifth one.